Hey guys.
Hello. 2.1, solving two-step equations.
That actually says 2.2.
Oh man.
Monday.
We're winning.
Okay, so you previously practiced doing one-step equations.
In
so
2.1. See, that's where I was. I was ahead of you.
Yep, you were, I get it. So now we're going to do two steps. So we may add, subtract, then multiply, divide.
Right.
So.
Same concept applies. You just undo whatever operation is shown.
Yep, and you're always going to start with the adding and subtracting. I guess I don't need to do that, do I? Go back down here. Okay.
Taparoo.
All right, so solving a two-step equation. What is the solution of 2x plus 11 equals 51? So what operations are used in this equation? So
Okay.
first I see
2 times x,
mm-hmm.
and then a plus 11.
So the first thing, and we always want to isolate the variable, right?
Correct.
So let's first get the x without the 11 there.
Right.
So I'm going to subtract this 11 off. And again, if you want to draw that line down,
subtract 11.
whatever I do to one side, I do to the other.
So 11 minus 11 is nothing, so you can just cancel it out.
Bump.
51 minus 11 is 40.
Bring down my equal sign.
Yep, and bring down your 2x. Now you ask yourself, what is happening between 2 and x? Well, they're married, so you have to divorce them.
Oh.
I know. So divorce is?
Divide.
Divide. I know. Right, because divorce is your last option, so here we go. It's the last thing you do here.
Well, there's another option, but I probably shouldn't talk about it.
40 divided by 2 is
20.
Again, the beautiful thing about this is you can check it. So you just plug in 20 for x, so it's 2 times 20 plus 11. Is that 51?
Well, this is
40.
40 plus 11 equals 51. It works.
Golden.
All right. Let's look at these down at the bottom. I'm gonna, should I move this away?
Yeah.
Probably.
Shimmer up. So we're looking at 2x plus 3 equals 15. So again, we're trying to isolate that x all alone. So the first thing we do, hey Mr. Farr.
Hi, Mr. Farr.
Is we need to subtract the 3. So get that 3 away from the x value. So what you do to one side, you do to the other. Subtract 3, subtract 3.
Oh boy.
So you bring down the 2x equals 12. How do you get the 2 away from x? Well, it says 2 times x, so to undo multiplication is division.
Man, this is going to look funny.
No.
I'll
Keep
just,
following.
and x equals 6.
Beautiful.
Again, plug it back in if you need to. Okay, this one looks a little scary.
Yep. 1, because it's written funny.
Mm-hmm.
It should be written better on your paper, hopefully.
So, yeah, on your paper it probably says t over 2.
Yep.
Okay, so the first thing we need to do is get rid of this random 3.
Right.
So we're going to add 3 this time because it's being subtracted.
Right. And so, guys, just because the variable is on the right side this time,
doesn't
matter. So it's the same operations.
Minus 3 here.
Plus 3.
Oops. Thanks. These cancel, and I'm left with t divided by 2 equals 2. Change my color.
8.
What? Oh my gosh.
That's what you get for making fun of me with the 2.1.
8.
Okay.
And 5 plus 3 is
6.
still 8.
It is still 8.
Got it. Wow. Okay. Now, have to undo what's happening over here.
Right. So it's t over 2 is what we typically say, but that does mean t divided by 2.
So I'm going to multiply this side by 2, or 2 over 1.
Because there's a hidden 1 in front of the t.
Diagonals cancel. T divided by 1 is just t. Oh, shoot.
Correct.
Ooh, there's not enough room on here. And then this, I'm going to multiply this side by 2 over 1, or 2, which is going to give me 16. Right? Is my math right so far?
Bingo.
Good. Bingo bongo.
Bingo bongo.
What you say. Let's keep going.
Okay. Ah, I knew it was going to show up on this slide. I knew it. I knew I did it. Sorry, dudes. Lots of space to work here for us.
Well, would have been real helpful. All done. Okay,
We're
here
your
we
teachers. You are lucky ducks. Lucky ducks.
We've got everything under
Don't
control.
worry about it.
All right, number 2, using an equation as a model. You take a moment.
No, I'm good. You guys better be paying attention.
Woo!
Yep.
A train. Oh no, people hate train problems. We're like totally doing
I
it.
know.
A train is 100 miles away from a station. It's approaching the station at 40 miles per hour. Let's highlight some of this bad boy. 40 miles per hour, and we're 100 miles away. How long will it take the train to arrive? So first, we need to define a variable, right?
Right.
And we're trying to figure out hours.
Yep. How long will it take for the train to arrive? So we're figuring out hours.
Okay. Well, I know that it is 100 miles away.
Mm-hmm.
So it's 40 times the hours equals 100.
Okay.
Got
so
it?
go back over how we got 40H. How'd you combine that?
Well, I know that he's driving 40 miles per hour.
Okay.
And I know that every hour he goes 40 miles.
Okay.
So each one of these hours would be multiplied by 40
Perfect.
up to the 100 miles.
Okay. And we don't know how many hours that's going to take.
Right, so we're trying to figure that out.
Got it.
Now, some of you guys probably would have done 100 divided by 40 equals h, which I get,
Yep.
but that's not an
Algebraic expression.
I mean, it is because it has the h in it, but it's
Right.
not. It's
So
not
you
up
want to set
par.
it equal to what it equals. How else can I word that? Well, you want it to equal 100. You
100.
don't want it to equal h.
Right.
So
right.
100 is your grand total that you're trying to solve
Mhm.
for.
So then we're going to divide by 40.
So we're undoing the multiplication.
Man, that's hard to see. So I'm left with h.
So 1h, just h.
Yep, equals whatever 100 divided by 40
Mhm.
is.
I don't think it's going to be pretty.
That's
Okay.
going to be what, 2?
Well, use your calculator.
Oh, I forget. We always have this guy over here. Okay.
There's no
100.
guessing in that.
Nope, shouldn't guess. Divided by, what am I dividing by?
40.
40. Where's the equals here? 2.5. Okay, so 2.5 hours.
Labels.
Or if you want to be super fancy, oh, I bet my head's about right here. 2 hours, 30 minutis.
Oh, beautiful.
You know minuti is Italian for minute?
I did not. I do now.
Math and Italian.
Yeah, you're welcome.
Okay, let's keep going. It doesn't want me to. There, oh,
Oh,
wait.
oh.
All right,
Okay.
using an equation as a model. Wow, you're making a bulletin board to advertise community service opportunities in your town,
Good for
guys.
you. Good
Such
for you.
givers. You plan to use half a sheet of construction paper for each ad. You need 5 sheets of construction paper for a title banner. You have a total of 18 sheets. So this is my total.
So I'll set it equal to 18.
Yes, so we're going to start with equals 18. How
Okay.
many ads can you make? So I'm trying to figure out A equals ads, right?
Yeah.
Okay.
So I see the other number I see in here is you need 5 sheets of construction paper for a title banner.
And I also,
That's all.
and I also use half
And I
a
use
sheet
half one for each ad.
for each ad. So that tells me I'm taking my papers and dividing them in 2, right?
Right.
So would I do, no, I would do 5
Mm-hmm.
over 2
Yeah.
times ads, right?
Yeah.
Okay. Now, why did I do 5 divided by 2? I've got 5 sheets total, or construction papers.
Right.
I'm dividing them by 2 because I'm, right?
Yeah.
Okay, because I'm using half a sheet. So then we're going to multiply this by the reciprocal.
Which means you just flip it.
2 over 5, diagonals cancel. I'm left with A
What you do to
equals
one side, do to the other.
I
Just
will.
multiply the other side by
5 over 2.
2 over 5.
Oh my god. Still, just delete. Go away. Delete, and let's actually write what I'm supposed to do. 2 over 5,
There you
because
go.
that's reciprocal. I'm going to set this over 1 and multiply straight across. 18 divided by 2 is what?
18 times 2.
Oh my gosh. Come on, Richardson. What is that, 39? Is that right?
I don't know.
36. 36. And then 1 times 5 is 5. So 36 divided by 5 gives me my total answer. 36 divided by 5. 7.2.
So it says, how many ads can you make? So how many ads, what would you accept as a final answer? Do you make 7.2 ads?
No, you can't make a 0.2 of an ad. That's
Right.
dumb.
So you can, do you round up?
No.
You round to
So-
7. And guys, this is one of those tricky problems that even if we would have divided and had 7.8, you would not round up to 8 because it's the real world problem.
Right. You can't have 0.8 of an ad. There's not miraculously extra paper somewhere.
Right.
So, all right. Okay. Wow. 2 terms in the, terms in the denominator. Solving with 2 terms in the denominator. There's not 2 terms down here. I don't know. Whatever. We're going to do it anyway.
I didn't make that up.
I didn't make that up
Okay.
either. All right, so the first thing, usually we start by subtracting the 5, right?
Right.
But this time we need to undo what's happening in the denominator.
Right. So if I wrote this out as a long expression, it would say x plus 5 in parentheses, and then the divided sign, 6. So the x and 5 are hooked together through the parentheses.
This is what we need to get rid of first.
Correct.
Over here, it's going to look like this. Multiply by 6 over 1.
Right.
The reason I do that, I want to cancel what's in the denominator. So that goes away, that goes away. I'm left with 1 in the denominator, which is just a placeholder.
Right.
Multiply this side by 6 over 1, and I'm left with, I'll use my fancy green, x plus 5, which is what was left on the top,
Right.
equals 15 times 6 over 1. Cool? So we're going to multiply this out. Man, I wish, here, I'll delete this. Erase here. We're going to have, I'm going to rewrite it down here. X plus 5 equals 15 times 6. Do you know what that is off the top of your head?
No. I don't need to.
90. Or 90 over 1.
Right.
Which is the same thing.
Right.
Now I have a one-step equation.
Yep. So you have to undo the addition that's next to the x.
Opposite of addition is subtraction, or inverse operation. And I'm left with x equals 85.
Perfect. And again, guys, you can go back and check that.
What's that?
problem.
Another example. Okay. So do we want to do this one?
No, you guys can.
Try that one out.
Yep, same steps as before.
Okay. What is the solution of 10 plus 2x equals 20? Justify each step. Now, when we say justify each step, just show your work.
Just show your work. What it technically means is you would have to write out the mathematical term for each one.
Like add or addition property of whatever.
Yeah, the equality property of addition.
Yeah.
Okay, we're not going to make you do that. So just go ahead and show us your work,
Every
and that's
single
how we're
step.
going to justify each step.
Using deductive reasoning, let's talk about what's deductive reasoning anyways. It's the process of reasoning logically from given statements to a conclusion. So it's basically thinking about what you're doing.
Right.
So the first thing we're going to do, I see this 10.
And this is a problem that kind of trips us up sometimes because the x is located towards the equal sign. But you still look at the first value or whatever value is not with the x, and you want to undo that to get it away.
So this is a positive 10.
Correct.
The opposite of 10 is negative 10 or subtract 10.
Right.
Do the same thing here. Again, draw that line if you need to. 2x
Bring down the 2x
equals
10.
And I almost said 30, not going to lie. I don't like red. I'll go back to, I'll use this. Undo multiplication.
Yep.
Left with x equals, do the same on this side, x equals 5.
Perfect.
Box around it, no need for a label.
So guys, on your test, we recommend you checking this because it's just an extra step that you're more than welcome to do. So you just have 10 plus 2, plug in the 5 for x, does that equal 20?
Well, this is 10.
Right? So 10 plus 10
Plus 10
is 20.
is 20. Yay.
Beautiful.
Okay. Last, lesson check. This is on the bottom of your notes. This is what we will be checking tomorrow when we see you.
On the flip side.
See ya.